Okay, this has another two-state binomial option pricing model example. In this case, we've got a put option. Same factors as before. Stock price is 100. The put has a strike of 110. The risk-free rate is 10%. And again, over the next period, the stock will either go up to 120 or decline. Again, and the probabilities or likelihood of each are the same. So all right, so again we have the stock and the current value is 100 and it can either go to 120 or decline to 90. So then the put option is can either go up, or the value of the put option in the up state is 0. And then in the down state, it's going to be the strike minus the stock price, which is, the strike is 110. The stock price in this case is 90. So the value of put is $20 in the down state. So now we calculate the hedge ratio. So the hedge ratio for a put is put up, the value of the put in the down, up state, minus the value of the put in the down state, and then the value of the stock divided by the value of the stock minus and the value of the stock in the up state minus the value of the stock in the down state. All right, so the value of the stock in the puts in the up state is 0. It's right here. The value of the stock in the down state is 20 there. So 0 minus 20 divided by 120, the value of the stock in the up state, value of the stock in the down state. So this is negative 2/3 is our hedge ratio. So what this tells us is that we need 3 puts to hedge 2 shares of stock. Okay, so our riskless portfolio okay, so we got 2 stocks and 3 puts, and then we've got the stock in the ups or the down state. So that's 2 shares of stock, and the up state is 2 times 90. That's 180. So and then the puts are worth 20. So 3 times 20 is 60. Yeah, that's 240. So, and then our stock in the up state is 120, and that's 2 times 120 is 240. And then the value of our puts is 0 in the up state. So that's 240. So in this case, we're going to buy the puts. We need to be long on the puts because we need to receive those payments, and when they in the event that the stock price falls. So okay, now we calculate the present value of our portfolio. Simply 240 divided by 1 plus the risk-free rate, or 1.1, and that's $218.18. Okay, so now our portfolio, our 2 stocks plus our 3 puts, this is S0, has to be equal $218.18. So this is 200 plus 3 puts is equal to $218.18. So here 3P is equal to 218.18 minus 200. So 3 puts is equal to $18.18. Cost of a put is equal to $6.06. So just so happened in this case that the price of the put and the call were identical. That will not always be the case. If we were to change this interest rate, for example, if we lowered it to 9%, that would increase the value of a put and decrease the value of a call. And here we can use put call parity to determine if we've accurately calculated the value of our put here. So because in the put call parity tells us the price of the put is equal to the call minus the stock price plus the PV of the strike. So remember the price of our call was $6.06. So stock price is 100, and then the present value of our strike is 110 divided by 1.1, which happens to be 100. So the value of the put is $6.06. But again, if you change this rate, it's going to change the value of both actually. But you can see that what the effect would be of a change in rate if you change the rate here as well. So that does it for binomial option pricing models and put call parity. So